Hi there. Hopefully everything gets up and running. Today is gonna be a rather short stream. I'm gonna change things up a bit. Um, since I'm both streaming on Twitch and YouTube is like my catalog of videos where I store every video of this process. I realized that there might be times where Twitch and YouTube kinda badly combined. So whenever I start hanging out, I'll change the overlay of the stream. Um, and I'll probably disable the YouTube stream since it then stores a separate video. And um, I'll name that separate video so that it sort of like gets stored as an episode of sorts. I think that would be a better way to do it, since following on YouTube would be more uh, like just watching some video tutorials. Um, in case I get a lot of viewers or even just viewers on YouTube, I'll of course not be able to just disable the stream, but uh, yeah. Um, yeah, but I'll test that out and figure out whatever works. Uh, Today will be a short stream because I'm really tired. Been at work all day and I have a long day ahead of me at work tomorrow. But since my girlfriend is working, um, I thought I might just do a little bit of programming and a little bit of streaming. So yeah, let's look at the roadmap. Uh, we have a couple of things to do so far. Uh, I wanted to be able to allocate specific sizes for our buffers. Um, Remember that we do create what is called committed resources, which means that they are created on an implicit heap. Um, yeah, I'm just waving around the mouse without pointing to anything specific, but yeah, and when we create these resources, they get placed at an implicit heap that we don't manage. It's fine for now. I don't think that heap management is something that we would get a lot out of diving into currently. Maybe eventually. Um, if you have uh, a platform, for instance, uh, a GPU with a lot smaller memory than modern day graphics cards, maybe you would like to do some heap management, and we will probably look into it down the road. But yeah, for just getting a prototype of sorts up and running without any optimizations, I'm not sure that we need it, at least for my hardware. Uh, I also wanted to mention before we get into things that I was completely mistaken. An upload heap is always on the GPU. The difference is in terms of how fast read and write operations are for either the GPU or the CPU. So in an upload heap, the CPU can read and write, but it is faster comparatively for the CPU um, than other modes of rather, I think the reading speed is faster than other modes of reading from the GPU memory. For example, readback isn't as fast, and the documentation shows you that um, um, it's probably only for read once operations. The same thing is said the other way around, that an upload heap should be somewhat read once from the GPU, write once, read once, then discard. So that's perfectly like uh, um, something that you would kind of use an uploader for. Just uh, read and write to a specific memory location once. All right. But yeah, enough about that. So I think the only thing we need to do to make this dynamically allocated in terms of size is just to create a size specifier. Since the resources are continuous in memory, so each byte is just stored in a continuous uh, um, row, or whatever we call them, of bytes. Um, so in essence, all resources get kind of wrapped around that. Maybe if I draw it out here, so it's like several memory slots uh, representing bits and bytes. So even if our data structure is 2D, it has a width and a height. Each cell gets stored, and the way you structure the data structure is what determines which uh, 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 bit, or rather byte, goes where, depending on the size of your data, of course. Yeah. So therefore, we can actually use just straight memory allocations to handle data. That also means that if we create an upload structure that transfers from the shared upload heap into a graphics um, heap, the default heap, we can just allocate a resource that has a certain size, and we can use that as a buffer where we segment our data into chunks and upload them once at a time. And then whenever we um, um, want to upload something else, we just use what's left in the buffer and start chunking again. So yeah, since it's linearly allocated memory, we can just keep on chunking and and uploading the specific parts of whatever data we want to store in memory. Yeah, that's a lot of talk. I'm kind of tired, so bear with me. I think that whenever we initialize our resource, we would like for one of the first parameters to be the size. So we probably would do something like a const unsigned int number of bytes and we don't want a default value for that. Whoops. There we go. Oh, I forgot the declaration. Let's see. All right, I think that should be it. Did I use it? Did I mess something up here? Heap type. Oh, of course, we have to do it in the correct order. Silly me. Yeah, I was kind of ambivalent in terms of doing a video tonight because I'm so tired and I have to really do a lot of work tomorrow, but I couldn't help myself. I had to do some development. All right. And you might recall that in NVIDIA Insight you can actually see the specific bytes in memory in whatever resource you allocate. Yeah. And for now we might just do these just for testing purposes. Let's see. Since no errors. Yeah. We will delete it whenever we have an actual upload structure, the linear buffer uploader. Let's see. There we go. And we need to check our components whenever we destroy our renderer. We would like to make sure that everything gets released correctly. So if we can have a command list, we want to make sure that it's closed. Thank you for read my code for pointing that out. Yeah, I did it the wrong way. Yeah, so that ended up giving us a DirectX12 error whenever we closed our application. So here we check whether we have a fence set. If we don't, we just reset the com pointers. Usually, if it's a null pointer, it doesn't really matter. So if there's a fence, we check if we have to wait for it. I don't think there's a need to print out that we're waiting. It was mostly for debugging purposes. And we call the intrinsic pause function. On Intel CPUs, it's supposed to have at least a slight advantage over other pausing methods. So, yeah. We use that one, but I'm not entirely certain that it matters too much. We might do SIMD optimizations way down the road, and then you will know more about intrinsics. I imagine building out functions that have an optimized version and a non-optimized version. Yeah, one thing I haven't mentioned is that I would like, yeah, this is just a COM pointer itself, so whenever it goes out of scope, it gets released. But does it go out of scope? It might sometimes be well, the renderer. Hmm, I'm uncertain whether a singleton actually is bound to the lifetime of the application from where the maybe it doesn't get uh, hmm, I'm actually unsure where such an object is managed from. Oh well. Anyway, let's get onwards. Yeah, I think that since this is a compiler, it gets reset whenever it goes out of scope. It has no subcomponents, so we do not need to write a specific method for that. This also does not have any subcomponents, so no release method for that. Let's see. Yeah. The adapter doesn't create anything. The factory doesn't really create anything either. Let's see. I'm just gonna check something out here. Oh, actually, just noticed that I have the just hanging out um, cover on my bed. Still kind of rusty. Or rather, not rusty. New to this whole thing. Let's see. Let's see. Okay. Our swap chain, it calls release. It drops the buffers. Whenever we drop the buffers, we reset them. And whenever we destroy our renderer, we flush before we actually call release. We reset the COM pointer just for the sake of it. And since it's stored in our renderer, yeah, so we have the heap. Do we release the heap whenever yeah, we do. So we reset the COM pointer for the heap. Let's see, let's close that one. And our device, probably already checked that one. I don't think we create anything here. Nope. And our resources, it calls release. Releases the internal memory of it and also the COM pointer. This also allows us to release it from outside if we just want to reinitialize with another size or something. The resource state manager, yeah, is fine. All right. Hopefully we do not get too many null pointer errors. Maybe, well, it's because I probably do not have them initialized yet. So let's test if it's actually set, and then we will call these methods. Since we're closing our application, branches are fine. As you might know, I'm not totally into doing a lot of needless branching, since it slows our CPU performance and hinders compiler optimizations. Therefore, I try to do as little branching as possible. And a component could always get released. So the problem was, I think that we might. So if I do this really quickly, yeah, nothing happens then. Yeah, fine. Even if we don't get to initialize them, yeah. No reason to get a crash whenever we close our application. That is kind of silly. It just gives you an extra click to handle some error message. There we go. All right. So let's create a new folder where we put in our linear allocator class, because we did that one, which means that our next task is to create a linear buffer uploader. The reason why I call it linear is because you could do what is called a ring buffer, where the buffer itself cycles over a specific buffer with a heads and a tails indicator, and yeah, that is a bit more complex. You have to do more gymnastics in terms of making sure that the heads and tails pointers are pointing correctly, in part to your data and in part to your destination. So a linear buffer is much simpler to use, but I would think that a ring buffer would allow you to more efficiently just stack different uploading jobs and have as efficient memory utilization as possible. Also, it would reduce, I would think, CPU cycles, but yeah. Let's not try to overcomplicate things and just do whatever will work for now. Since I do like to have a fairly easy task to start out on a video series, or rather a video, I'll move the depth stencil up here, since I'm pretty sure I won't be doing anything else than either the start of the linear buffer uploader or perhaps the entirety of it. But yeah, this video will not be any longer than that. Therefore, I'm saving the depth stencil stuff for the video that comes after this one. Since it's fairly easy to implement a basic depth stencil, then we can get into the more complicated stuff of doing a DirectX12 pipeline. Yeah, so a linear buffer uploader. I'm unsure whether I should do it in Paint or Draw IO. Imagine that you have a chunk of data. I have to do it somewhat. If I hold down Shift, things will get more straight. Anyway, imagine that is evenly sized bytes in a chunk of data. As you saw in the last video, when I showed you the NVIDIA Insight stuff, when we create a chunk of data, a resource on the GPU, it's empty. We can create a set of data on the CPU. Let's see. Whoops. And we can actually store that in the upload heap, which is a part of GPU memory. Whoops. Oh, it really doesn't matter. We can store that in an upload heap, which is a special heap on the GPU where the CPU has write access, and we can sort of, oh wow, we can't do them diagonally. Anyway, I'll do this. Paint really got advanced since the 90s. Anyway, so we can store the data in the upload heap, and from there we can pass it to our default heap. So the idea is that we create a permanent resource that resides in the upload heap, which is our upload buffer, and the size doesn't really matter much. I'm pretty sure there are, or rather that is somewhat wrong, but in theory, with no hardware limitations, it doesn't matter much which size it is, because the idea is that we take a small chunk of data that we want to get into a GPU-based heap. Let's see. So let's say that this is the entirety of the GPU memory. We have this small data chunk that we would like to upload to really can't get the grasp of having an object selected, even though I can't see it. Anyway, let's say we want to store it here. We simply take whatever data we have. I have to put that as black. And temporarily do I want? Yeah, temporarily store it. Store each byte in our buffer, and we store that in the part of GPU memory we want to store it in, and the same thing goes for the next chunk of data. We simply store that inside our buffer. Let's see. But as you can see here, the chunk might be too large. Therefore, we overwrite. Let's see, I didn't deselect. So we overwrite whoa, this part of our buffer and rewrite it with the last part of our data. And we store it. I have to change the figure, of course. I'm sorry. I hope you get some cheap laughs out of watching me fool around in Paint. Yeah, so the whole data block here, imagine this is the start of this memory block of data, and that is the last part. Yeah, that is what's going on actually in a ring buffer. Linear buffer might be even simpler. Maybe we will just start at 0 and fill the buffer with the full length of a chunk, which of course will be the buffer size, and keep on doing that until we reach the end chunk that is smaller than the actual buffer, and then we're done. Yeah, a ring buffer just wraps it around, wraps the start of the data around, and moves the last part of the data forward and to the start of the underlying buffer. If it ever reaches its own starting point, it of course chunks it, so a chunk can only be the total size of the buffer anyway. But yeah, I think you can imagine situations where you get the most efficient memory utilization when you do it by using the ring method. In the linear method, sometimes there will be parts of the buffer which are unused, but yeah. You can always do an optimization if you want to, and if you want to play around with adding a heads and tails indicator and calculating where you are in terms of the input data and where that gets you in terms of the internal buffer heads and tails pointers, yeah, feel free to do that. I've done it in myself, but yeah, I think this will be easier to follow. A linear buffer will be easier to follow. Anyway, that's a bit about memory management in DirectX. There are different ways to handle memory allocation. So let's do a linear buffer uploader, or rather a linear uploader. I'm sure. Unsure. Usually, you name a ring buffer a ring buffer. uh, Maybe we just want to call it a linear buffer. Uh, it's not really part of a DirectX uh, API component. Yeah, maybe I just. Hmm. But it does use DirectX12. Well, it's inside a DirectX12 subfolder, so if I don't call it anything, you should realize that it's using DirectX12. Yeah. I mean, everything is named after whatever underlying component they have, and the command lists and command queue managers have several objects. The command queues will have fences as well as command queues and several different ones. So I think it's fair they're called DirectX 12. Yeah, doesn't really matter as long as you can remember whatever your classes do. You should be fine. Did I ever actually explain why I use GXE? Um, it's comprised of. Actually, the G has a personal meaning to me, but uh, you might as well just call it. Think that it stands for generic and DirectX engine. Yeah. Some might say, are you making a game engine? Which I'm not. But in order to make a game, you have to make something that is almost an engine. But an engine is an entirely bigger undertaking than just creating the necessary structures to create an actual game. Of course, if you have to create a game that has a lot of scope, you would have to develop tools as you go along, and your project might take the shape of a somewhat basic game engine. Yeah, but since this is compiled into a DLL, you could easily replace the game layer, or rather project, with something like an engine, or perhaps even combine um, three projects where they both reference the engine, and one is the editor layer and one is a game layer. You could also move some of these components, perhaps not the renderer, but some of the other components into the actual game project. Perhaps you want game logic there, and just reference the renderer or other parts of the system, audio and some simulation systems. But yeah, this way our game so far doesn't really represent anything other than a main function, and we do sort of create a game engine. Anyway, I seem to be talking a lot. Hopefully you don't mind too much. Yeah. So, whenever we create a linear buffer, we would like for our system to be able to create a empty linear buffer. For instance, we would like to store one in our renderer. For instance, let's make this system objects and call this system variables. Then we would place a linear buffer here. Since it's something that you probably would use a lot, the renderer would allocate and deallocate stuff all the time. Yeah, so we also would like a initialization method. We could also create an explicit constructor, but yeah, we're not gonna do that. So in general, this will look a lot like a resource, therefore we copy that. We do not need any of the other parameters because they will be set internally. We would like to be able to specify how much internal size the buffer has. What is the standard alignment? Alignment just means how much memory is actually allocated for a resource in memory. It has 64 kilobytes. That would mean that our data would get chunked into 64 kilobytes. Yeah. We will probably do a lot of resources that is somewhat smaller than 64 kilobytes. Yeah, a lot of resources actually. Imagine just having a struct of uh, 64-bit integers that would be like 32 bytes, not kilobytes. So yeah, that is probably totally fine. So that is so therefore we will of course it has to be a void function, or rather void return type. Yeah, so that will make sure that we do not have any spacing in our buffer. And in case we have something larger than 64 kilobytes, we just end up chunking it. So first, we actually do a lot of what we do in this function. Let's see. We do know that we want an upload heap, and we do want a buffer size. We do want a initial state of generic read, and we do want a COM pointer. Let's see. Of a ID 3D12 resource m buffer. And since we will be creating this as an uh, component of the renderer, time has shown me that I have to include the actual headers. For everything else that doesn't get included, you can just expect it for it to use the PCH file. For instance, these header files are perfectly fine with it without any includes, since the PCH file takes care of any includes. But you can't be certain that everything gets handled correctly when you include these files. Yeah. So you might end up getting a lot of errors. So have that in mind. Let's see. D3D12. I think that is defined. Yeah, it's defined in D3D12. Okay. And we, of course, store it in our buffer instead. So whenever we initialize a linear buffer, we create the buffer. And we also want a release function since we now have a buffer. And we want to check if our buffer has been set. If it has, we want to in part release it internally and reset the buffer pointer so that we can do initialization all over again. Perhaps we want a different size linear buffer or whatever. And of course we create the destructor as well. It should call the release method, even though it would release the actual COM pointer itself. It might not release the underlying resource. So yeah. Yeah, I'm actually uncertain whether it actually deallocates the heap if we do not call release. We can look it up. So ID 3D12 resource, and let's see, in header it's from pageable. Well, core interfaces. Well, it might be more of a hassle to look up that release function than I imagined. Let's see. Anyway, all right. ID 3D12 resource release, maybe. Anyway, that might be a question for a later day. Let's see. It's on the DXGI unknown. Now I get stubborn. I think buffer net I unknown. Oh well, it just decrements the reference count, which I actually think would mean that this is doing the same thing. The reset internal release. Yeah, it just calls release on the underlying object. So yeah, I'll stop doing that. It doesn't really make any sense then. Let's see. There we go. There we go. Do we have anything like that in our swap chain? Nope, we do not. There we go. All right. So now we have to get into the somewhat harder part. We have to do a method called upload, and we have to do a i3D12 resource pointer, and since I'm used to working with OpenCV, where you always specify the source first, I will try to do that. Mind you that I might have a different opinion on another day. And we do a destination. Or rather, no. We actually do not want to copy from a resource. We would like to copy from directly from a memory allocation, which means that we could pass in an integer, we could pass in extract, whatever. We would just like to specify how large it is. And yeah, this is a really simple version for now. So wait a minute. Source, this has to be destination. This is the source. Yeah, okay, I'll do destination first. So the destination in terms of resource, the void pointer to our memory, and the size of whatever data we have. Let's see. So for instance, instead of creating a shared resource here, creating a value and mapping that into our resource. We will sort of do this. Let's see. Yeah, inside our buffer. So this code is somewhat needed to complete this step. So if size you could do error checking before, but let's return if the size is below 0. Or rather, yeah. I might be tired, but I'm unsure that yeah, so for whatever reason, we get a function call where our size is below or equal to 0. We will simply return. We have nothing to do. I might change this, but yeah. We also would like a unsigned int called buffer size, which gets initialized to 0. And this is basically whatever buffer size we set. By the way, we would like to use our helper function to evaluate this, since we would like to throw an exception if this fails, because it will be an essential component, at least for now. We can always revert that, but let's see. Now we do get an exception if it doesn't succeed. Anyway, and we did tell it to be a buffer up. Let's see. Okay. We also need to do some chunking. And this means that we will have to add parameters to this function, because if the resource size actually, yeah, that's why we create a wrapper. We could do get description and get the size of it. We could do that if we want to, but that gets fairly extensive. Get the width. Yeah, and maybe if we want to reuse the logic for texture uploading, sometime it won't support that. Let's see. If we do give our D3D, rather D12 resource, a function that stores our size, we do not want, yeah, yeah. What about if we allocate sub-resources into a resource and the, yeah, I think this has to be a member variable that is fetchable. So we do a unsigned int size, and we return the size. And of course we have to, during our initialization method, set the size to our byte size. Yeah, so instead of taking the the DirectX version resource, we will take our own resource wrapper, the 12 resource pointer, since we don't want to copy our resource. All right, so oh, it's getting late. Hopefully I will get this done before we end the stream. Anyway, if the size is larger than our buffer size, well, we could do some error checking here. If it's smaller than our actual size, we would also like to return, since if there's not enough space in the destination, yeah, the data will never fit. Anyway, if the size of the data chunk is larger than our buffer size, we would like to chunk the data. Meaning that we would like to chunk let's just do ints size after chunk is equal to the size minus the buffer size and then we have whatever is left. If it's several buffer sizes, this will be quite large. Yeah, but then we could actually call the upload method by passing in the destination, the memory, but the size after chunk. After chunking, I know this won't work, but imagine that we take out a chunk and we say whatever is left of that chunk, we pass it on to the function itself. It runs again. It has the same destination. It has the same pointer to a location in memory, but it has a smaller size. It says, oh, am I under the size of the buffer size now? If it's not, it will do another chunk that it will pass in to the loop. And if that chunk is sufficiently small so that it fits in a single buffer, we will start copying that chunk over. But it's the actual last part of the memory. And whenever that returns, this function will return in the previous part of the loop, and that part of the memory will get mapped and copied over, and then it will return again, and then the first part of the memory will get copied over. So therefore, we need to work with offsets. Yeah. So we have to pass in an offset. In terms of the original memory location. And we have to be able to calculate how far in we are. Let's see. I think that the actual chunk size is the offset, as well as the size, isn't it? Let's see. Let's first do I think there should be cost anyway. Let's see. There we go. So let's just run through this again. For instance, we get something that is 1.5 times 64 kilobyte. So that is 98,304 bytes. That is our test case for now. So this pointer points to a location somewhere in memory. This is a resource, therefore, if it's large enough, since alignment says that you have to allocate at least 64 kilobytes and align data within chunks of 64 kilobytes, this destination will be 128 kilobytes no matter what, if this has to do anything. So first we check it has the proper size. We will realize that is fine. We will see that the let me see, it's 96 kilobytes of memory is larger than our buffer, so we have to chunk. We will slice off 64 kilobytes and have 32 kilobytes left, meaning our sizing after chunking is 32 kilobytes. So we pass on the last 32 kilobytes, but, or rather, let's see. So that would mean that the offset is actually the buffer size, because whatever we pass in here, I'll go through other cases, so we will make sure that this is fine or not. So we pass in our buffer size since we cut off the last part of the data, the last 32 kilobytes. We will tell the method that you still have to copy into that resource. It's still from this pointer in terms of memory. It has a size of 32 kilobytes, and you have to place it, both place and read, at an offset of the buffer size, which got cut off. We do that whenever we map. We map the pointer just to our local resource, and we copy with the specified offset for the amount of size. All right. Let's just check if this works if we do something like let's say 3.5 times 64 kilobytes. So let's test it out with, so, and let's just do some let's see, some tests. So first time we pass through the loop, we have a chunk of that. I don't think this will work, because we need a division to figure out how many offsets we have to offset, because now that we have multiple offsets, as you can see here, let me just calculate that. We will be left at a size of that many bytes. We would pass in an offset that is our buffer size. Let's imagine that we get to here. We calculate that this is the amount of size that is left after biting off a chunk. We pass in that, but we would pass in our buffer size as the offset. But now when this loop starts again, we start off with this value, but we have to subtract 64 kilobytes. Let's just see what that would be. It would be, of course, the value we had before. Anyway, we would again tell the algorithm that we would have to place it at the same offset, meaning that yeah, we wouldn't really get anywhere. So we have to calculate our offset in a different way. What is the way? I'm not gonna look up old code, I'm just gonna contemplate it a bit. So the first chunk offsets everything by the buffer size. We could use an internal value that tracks how many chunks we do, but I don't think that would be super smooth. Hmm. Hmm. Yeah. There's something in the way we calculate the offset. So we first start bite off the chunk. In case we only do one chunk, the offset is always correct because the first chunk will be the first part of the data. If we have several chunks, the first one will always have an offset of 0. Well, maybe this is... No, it's not correct. Maybe it's offset plus the buffer size. Let's test this out. The first time our offset is 0. For that case, everything works the same. We would end up, if it's less than 2 buffers of size, we would end up with an offset of exactly the buffer size, and the last part would be copied over first. Therefore, we would return and just copy over the first part. If we have several cycles, the first time the buffer, the offset would be that. If we have to bite off a new chunk, the offset would be that. Let's see, if we bite off another chunk, we would be left with that many bytes, and our offset would be this. So if we add this to our offset, we get a value of yeah, if we start the offset and we add in whatever chunk we have left, that gets placed at the last part. That function returns. We place the next bytes at this offset. That function returns. We place whatever needed at this place in offset. That function returns, and we store whatever started at 0. Let me see. So we bite off a chunk. Yeah, let me see. Yeah, and I told the calculator I wanted 3.5. 3.5 cycles. So this means that the last time we will get in 32,768 bytes, and we will place them at this offset. So actually we have to move these for them to make sense. Yeah. Yeah, that should work. Then we map our buffer get and map it like that. We wait a bit. Let's see if, let's just see, shouldn't get an error, but we might. Let's see if our buffer is set, we unmap it. Usually you don't have to unmap before you deallocate. let's see. I think it's a null pointer. Yeah. All right. Perhaps. Maybe I would like to. Void pointer, internal pointer. All right. We map it. Let's see, instead of a map pointer, we will use our internal pointer. And of course, increase it. Let's see, we don't have to cast it as a memory variable. Yeah, I'm getting really tired. So we copy. Wait a minute. Yeah. So yeah, we want to copy the buffer size, or rather, let's say that we have an unsigned int called new size, which is equal to size, and we set the new size to our buffer size in case we changed. So in case we need to chunk, our first chunk will have the size of a new size. We will copy that into our memory, void pointer, local pointer should be equal to plus the size t of the offset Isn't that the correct syntax? Let's see, increase pointer C++ byte. Let's see. Am I supposed to do a byte pointer instead? Let's see. I think so. Let's just test this out. Let's just print out the value of our pointer. I'm unsure how I do the pointer arithmetics. So I would like the pointer to move with the offset. We have a void pointer. That is supposed to be moved by the offset. Maybe there's another version of memcopy that is more safe to use. Let me just look it up. Offset C. Pep, pep. adding an int offset. Yeah, I think that it would probably work. Whether it's safe, I'm not sure of. Let's see. I need to look up the documentation for the memcopy. Would I rather do another form of memcopying? Offset. Add 50 to 81. Uh, uh, yes, of course. Yes, of course. Oh my god. That is so stupid of me. Or rather, is it that stupid? Let's see. I must be tired. Yeah, I moved the source pointer. Yeah, I think this will work. So I think that should be fine. Let's just first test it out by, since this creates an internal buffer that we can look up in Insight. Let's just see. Let's disable this for now. And let's do a. Yeah, I'm getting really tired. Not resources, memory, linear buffer. Hopefully we will be done soon. We initialize by using our device. Let's see what where are our errors? What happened? Let's see. Error default argument. Okay, I'm passing something that is not supposed to be defaulted. There we go. And let's see. Let's check out Insight graphics and see what our application creates for us. 1200 frames until it started synchronizing. So it created the buffer on the upload heap. It's empty, nothing happens. So we have that as a baseline. We create the buffer, everything seems to be working in that regard. Let's try to upload some data. Right now we just want a resource that has a size of 16 units. We pass in our address. We would like for a uint64 test value to be initialized into memory. We will reference it but cast it to, oh well, it accepts it as a memory address of that. Let's pass in the size of a uint64 as our test, and we don't want an offset. So this should easily be stored in our buffer. Let's see. So yeah, I think that should be correct. Let's just do a comparison. I'm glad I didn't delete the old code. Yeah, so now we can use the old method, which we know will be working. So let's just recompile this and try to run it again. Insight stopped crashing after we got rid of the bugs, it seems. So yeah, 154 and 2 in the second byte. We see that this is the absolutely same, so our memcopy works. Now we have to test something that is fairly big. Uh, yeah, well, maybe that is something that we would do eventually. Yeah, I'm getting really, really tired. I think this should work. Now I'll just check out what I did in a previous implementation of the ring buffer. Let's see. Yeah, you calculate. Yeah, I think this is correct. You do pointer arithmetics. And this. Yeah, I think this should be correct. Anyway, let's see if we. Well, we actually found that we would like this to store a reference, or rather pointer to a graphics command list. We could allow it to fetch from the actual command list manager, but I would like to know whenever we do make calls to our graphics command list and build our command lists that it's obvious from the render code. Let's see, we delete that old comment, doesn't need to be there anymore. Yeah, so I think instead of leaving an easy task as the depth stencil, we will leave uh, a future task to do testing with objects larger than 64 kilobytes. And also store a no, let's just fix that immediately. So of course we do not need to store the pointer. It doesn't make any sense to store it whenever we do calls to a uh, 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 um, whenever we do calls to the upload method of this linear buffer. Uh, uh, um, let's see, should be fine, right? Ah, yeah. There we go. Yeah, we could do some error checking or whatever. if we wanted to. Maybe sometime down the road we would like to throw exceptions here and there. I think this should throw an exception. Should we just implement it straight away? Destination resource. Get resource. And the destination offset let's see, is equal to offset our source buffer is our buffer, and our source offset let's see, the destination offset is supposed to be the offset, the source offset. There we go. So our internal buffer always starts at 0 and copies whatever chunk we want to copy over. I think this should be fairly correct. Let's see. There we go. So now we test this out. Doesn't seem like now we get any errors. Let's see. Does it still work? Because then we only have to do testing with larger objects. I think this might be fine though. I think we got most things correct. So the internal buffer has that state, and the GPU side also got the data. So at least something works. Let's see. Yeah, we don't copy anywhere. We only map the shared resource. No need for that. Let's see. And we do check it in Insights. And this should be empty. It's empty. This should, yes, yes. And then we could of course do something like do it again, and then change the value. Oops. And let's see, 32, 32. Still nothing here. Yeah, so it overwrites the buffer every time. at least, okay, let's say that we transfer a struct random. It has a UN64, one called 666, and another called 32. So if we upload that and then upload an integer, we should see that our buffer doesn't get zeroed out. Let's see, maybe we want the mapping stuff from before as well, just to show you the difference. So let's say we have a void pointer, map pointer, which is null pointer, and then we do shared resource get resource map, and we do a sub resource of 0, 0, and store the pointer in map pointer, and we do a mem copy from to our destination in map pointer, and from a reference to test value 2, and the size of int uint64, and we of course move that up here as well as these two, since we have several test values, and then we unmap. 0, 0. And just because it's really oh, sorry, I didn't see your message. Let me see. No, I'm just a hobbyist. I have another job in an entirely different field as a full-time job. Do you work in the game industry? Let's just test this out. I'll be watching chat for now. Let's see. Let's see. Oh yeah. Let's see. So our shared buffer has a 32. This one has 32, 32, which our upload buffer actually does as well. I think something went wrong here. Yeah. Suppose I don't do that. let's see, where did I make an error? Ah, I didn't make an error. I just tried to recompile something that was running in the background. So let's see. Yeah, this should be different. So yeah, the first part bytes, the first 2 bytes doesn't get transferred correctly. Yeah, so I did something wrong. Ah, I know why. I know why. I might know why at least. Let's see. Let's see. So, is it because yeah, you should do implicit conversions, but let's just be explicit. Yeah, that works fine. We don't use test value. Well, I guess it actually works. Yeah, I guess it actually works because I realize that it's not a mistake in the code. It's because I first upload the struct, then I upload the integer, which is smaller, so therefore in the destination it gets placed in the first bits, the first bytes. So if I swap these around, and we should of course choose a different number since we have 3 different numbers in play here. Now we should see a difference. First we upload the test value, then we upload the structure, which should overwrite. So I think the code is correct. I'm just not understanding my own code correctly. It's not a bug. Yeah. So this should mean that we only have to do, so the destination resource now has the data of the struct. The buffer here also has the struct. Let's see. Yeah, and this has a totally different value. I really wanted to show that the buffer only will it will never reset the internal memory, which means that you should be wary of bugs in general when you're doing this kind of code. Otherwise, you will end up uploading the wrong information. But I do think that our code might be sufficiently robust that we shouldn't run into any problems. Yeah, we still have to do debugging with very, very large objects. Uh, Perhaps. Let's see. Initialize array. I know I keep on saying that I won't be doing anymore, but I really want to. Let's see. Anyway, initialize array C++ int 0. Yeah. So 64 kilobytes size of uint. I actually think, yeah, should be 8 bytes, right? Yeah, it should. I know it's 8 bytes. I'm just checking to be sure. I feel kind of silly. I guess I don't trust myself. Yeah, 8 bytes. All right. So if we do an array, let's say to have 64 kilobytes of uint 64s, we have to do an array of 8192, and we will initialize all of them as 666. Sorry to any Christians out there. Then we will, or whatever culture I might be offending. Now you gave me a bad conscience. I will immediately redo this. Let's do 32 then, and let's say that we want another half 32 kilobytes of data that gets stored as perhaps just ones. Yeah. Let's try to upload that. So this should be more than 64 kilobytes. We initialize them all as the stated numbers. Let's see. I think everything should still be fine. Well, of course nothing happens because um, this isn't large enough. So let's do 16. No, 2 times, no, 4 times 16 times 1024. So that should be 4 times 16 kilobytes. Let's see. We have a very large buffer, but nothing happens. Our buffer here doesn't do anything. Maybe it's because, yeah, I deleted the wrong one. Whoops. Let's see, 32, 32. Something is wrong here. Let's see. Let's just create this and try to map the values into that as a test. Let's see. So this buffer doesn't do anything either, which means it's possibly our struct. Let's see. Is there a fast way? Yeah. Okay, let's use the algorithm then. For now, just for testing, fill in so values. Let's see, let's do 0 then. std fill in the destination 1 and the count and the value. So let's do 32 again and then fill the 2 with A1. Alright, there we go. Let's see. So the first part still doesn't work. Am I doing something wrong here? Huh? Now everything is set to 32. Yeah, okay. So I still think it's something in terms of the it should. It's definitely not filling the struct with the values I expected it to fill. It still fills the first part of... Ah, whoops. Whoops. Man, I feel stupid sometimes when I realize something like that. Maybe everything got worked all along. The filling of the arrays probably weren't working, so we might not see expected results anyway, but so this is blank. Huh. This has 32 in the first byte forever. And no other information. The buffer here. Yeah, about half of the buffer has the the last part of the let's see. Isn't it large enough? Let's just double it. Let's see. This is because I allocated too big of a struct. Maybe I did. Something happened, but at least we got the first part correct now. Let's see, the buffer only got that part. This one has everything correct. Yeah. So the struct gets created correctly here, but yeah, and everything just gets mapped as it should. But this doesn't get the second part. Yeah, this one just repeats. Let's see. Yeah, we need to do debugging. I won't be spending any more time today on it. We still have to do debugging. Alright, one last time. Whenever we step into this method, I will be testing out the values, the locals. So let's let's say that we want to step into the function here. Size is that. Our internal size is that. So it's supposed to be bigger. New size has some garbage value. Let's see. We calculate the new size. We bite off a chunk and pass in an offset value. So we have a new size equal to the size, which is supposed to be so right now we place it at the offset. Let's see. Does that change anything? Let's not do that. Yeah, it changes something, all right. Void pointer. Yeah, there's something about the pointer arithmetics here. Let's change it back to the old version. That worked somewhat. shouldn't be working. So the buffer gets the last half. Yeah. Either it's the mm, yeah. All right. I'll be doing the debugging, the debugging in a later episode. I hope you found any of this helpful. Remember, you can always look up my old videos on YouTube. Feel free to like, comment, subscribe, or even follow here at Twitter. I will be seeing you in the next episode. Have a great one. Bye bye.